So before the break, we just went over how to multiply, okay? Either one term, how to square, okay? And then the reason why we learned that is because of the next topic that we want to do, okay? This is called the rationalized denominator. So denominator, you all know what that is, right? Rationalize, let's understand what that means. It has to do with rational numbers. Okay, so let's understand what is considered as rational numbers. How is it different from irrational numbers? Does anyone have a definition or heard of it? What's irrational numbers? Anyone? Colin, have you heard of rational numbers?
You just can't have square roots in the denominator.
Rational numbers. We're not talking about denominator, just in general, what is a rational numbers?
Oh, like something that doesn't like end.
Something that doesn't end. So something that doesn't end, can you give me an example?
Like pi.
Pi, okay, so pi, is that a rational or irrational?
That's rational, right?
Okay, so actually the opposite, it will be irrational, right? It's like when you hear the word irrational, it's like it doesn't make sense, right? You are being irrational, right? You are saying something that's irrational. So pi is a number that goes on forever. It doesn't have a pattern to it. So it's like going crazy, right? So that number is irrational, okay? You can think of it that way. So rational number will be something that can end, okay? Like 2.5, that's rational, right? It's a clear number, all right? So you are being rational, right? You are being very clear of your decisions. So rational number is any number that can be written as a fraction. Okay, this will be the definition for a rational number. A number that can be written as a fraction. So for example, like 2.5. How do you write that as a fraction? Brennan?
Like
2.
as a mixed fraction or improper?
Doesn't matter, as a fraction.
Just 2 and 1 over 2.
Yeah, very good. Okay, so 2.5, I can write it as 2 and 1 over 2, right? That's a fraction. If you want to put pi as a fraction, then that would be impossible. Okay, so pi is irrational. So what's the other irrational number you can think of? Aaron, what's another irrational other than pi?
It's like a root number that isn't a perfect square.
Yeah, very good. Okay, so irrational numbers. So it will be any number that cannot become a fraction. So for example, will be pi, or something that is the square root of not a perfect square. So let's say 5, right? If you type it into calculator, it will be 2 point something, and that goes crazy, right? After that, it's just random numbers. So that's irrational, right? If it's a square root of 4, then that will be rational, okay? Because square root of 4 will become 2, right? And 2, you can write it as a fraction. So numbers like those are irrational, right? Square root 5, square root of 7, right? Etc. Okay, so rationalized denominator means we want to make something that's irrational become rational. Okay, rationalize is like a verb, okay? You are doing an action, doing something to the number, used to be irrational. You want to make it rational. Okay, so you want to make root 5 into something that's rational, okay? Root 7, turn it into rational, even though it's irrational right now, all right? So there are two kinds of questions. You only focus on denominator. So when the denominator has an irrational number, like this one, right? Denominator, you have a square root 2. So this one, right? This denominator here is irrational. You want to make the denominator become rational. So if the denominator has one term, you multiply by the same radical, okay? And then we will be talking about what if the denominator has two terms, like this one. Root 6 is irrational, right? So root 6 plus 1 is still irrational. Okay, that's on the next page, right? Page 27. So that's two terms. What do? We can multiply by conjugate. Okay, we'll get to that in a sec. So we'll start with one term. So if you see a square root 2, you just multiply by the same irrational numbers. So you'll multiply by square root of 2 in the denominator and also the same thing on the top, because eventually you are just multiplying by 1, right? When you multiply by 1, you did not change the question, then that's okay. Okay, so when the denominator has one term, then you just multiply by the same radical. Okay, so let's see what happens when you multiply by the same one. So square root 2 times square root 2 is x squared, right? So we know from the last page, it becomes 2. And then the top, 3 times root 2. 3 is on the outside, 2 is on the inside, so they cannot multiply together. So you can only write it beside each other. Okay, so now if you look at the denominator, used to be irrational, now it's rational. So this process is called rationalize the denominator. Okay, rationalize denominator. Okay, understand that's why we call this rationalizing denominator. So let's look at question B. We have two ways to do this question, okay? So let's see which way you guys want to do. Right, so how about Yosher, how do you want to do B?
Simplify first and then rationalize.
Okay, so what do you mean by that?
You turn the root 8 and then you simplify it into 4 root 2.
Okay, so the square root of 8, you can do that on the side. Let's write it on the side. Okay. Root 8, right? If you take the pairs of 2 out, it can become 2 root 2. Right? So 2 goes out, it will meet the outside 2, makes it a 4 root 2. Okay, so you simplify it first. Now, what do we do next? You sure?
And then you multiply top and bottom by root 2.
Okay, yeah, so you only need to multiply the irrational number. Okay, 4 is rational, right? So you don't need to touch that. So just multiply the part that has irrational. Okay, and Colin, can you carry over? What do we do now?
So the 2, you can cross them out.
What do you mean, cross them out?
So like you can
like that.
no like you can just get rid of the square root.
Oh, okay. So the denominator will be
8.
8. Okay, so it'll be 4 times 2, that's 8. And then the numerator,
Would be 3 root 10.
yeah, 3 root 10. And then make sure you double check, right? The 10, is this simplified or not, right? So if it's simplified, right, 10 is only 2 times 5, right? Not, no pairs. Then you leave it as it is. That's your answer. Okay, so this way is you simplify first. You look at the 8, we can take something out, we do that right away. Okay, let's say if we don't do that, right? Let's say we just start rationalize right away. So 3 root 5 over 2 root 8. Instead of taking the pairs of 2 out, I'm going to just start by rationalize right away. So we'll multiply root 8 over root 8. Right? Because 8 is, square root 8 is irrational. So let's see what difference it makes. Okay. Nathan, what do you get now for the denominator?
You get you just get like 2.
Yeah. That's it?
Actually, no. 16.
16, very good. Okay, so root 8 times root 8 becomes 8. So 8 times 2, 16. And the numerator, Eric?
I think it's 3 times root 40.
Yeah, 3 times root 40. So you can see that the answer is different, right? So that means it's not finished yet. So if you look at the 40, I can still take pairs out, right? 40, you can think of it as 4 times 10, right? You can do on the side. 40 is 4 times 10. So 4 is a perfect square, you make it go out. So 2 root 10. Right? So the 2 goes out, meets with the 3, and that will give you the 6 root 10 over 16. Now remember, for dividing, outside can divide with outside, right? So 16 and 6, they can reduce, makes us 3 and 8. And finally, it matches the answer on the left side. So you can see that if you rationalize first, right away, sometimes it takes longer, right? It takes 2 extra steps. So make sure you always check the numbers to see if there's anything you can simplify first, right? Make the number go smaller before you start to do rationalize, okay? So we would prefer the first way, right? Because right away you see 8, and we can do something to the 8, right? You do that first, okay? And you still eventually reach the same answer, just the first way will save a little bit, right? So I'm gonna let you guys to do the bottom 8 questions, and each one of you will get a chance to show your answer, okay? For question C, you have a square root of a fraction. This one you can split it, right? Because inside with inside, right? So it's the same as root 5 over root 8. Okay, they mean the same thing, and then you can go from there, okay, to simplify or rationalize. So at the end, your denominator cannot have square roots, right? Because rationalize means you make the denominator become a rational number. Okay, so I'll let you try all these 8 questions. Probably take about 10 minutes maximum, okay? And I'll go over, all right? Raise your hand if you finish early. You can let me know any questions, okay, if you are not sure if you're doing it right. Okay, Eric, which question are you on?
G.
Okay. Okay, I think first one very similar to A. Okay, so I'm just gonna do it for you guys. Okay, I'll do A times root 2 over root 2. So that makes 2 root 2 on the top, right? Outside with outside, so 2 cancel with the 2. So ends up with root 2, okay? All right, Brendan, what's your answer for B? Final answer.
Final answer got 3 root 5 over 5.
Okay. And Colin, C?
I got root 10 over 4.
10 over 4. Nathan?
Yeah.
Huh? What is it?
Which number D?
Yeah, question D.
Root 2 over 8.
Root 2 over 8. Okay. And Sarah, question E.
3 root 61 over 488.
488. Wow, big number. Okay. Yosher, F.
Root 5 over 40.
Root 5
Yeah,
over
40.
40. Okay. Right, so Aaron and Eric almost done.
Yeah.
Okay. So far, any different answers from you guys?
Wait, Jason, I think I did B wrong. I think it's 3 root 5 over 10.
3 root 5 over 10.
Mhm.
Okay. Anyone want to adding answers? Share your, anyone got different ones?
For B, I got the original one written
Oh,
there.
okay, okay. We'll keep it there. Okay, Aaron, G.
I got root 2.
Okay, just root 2.
Yeah.
Okay. Eric, last one.
I have 3 root 60 over 40.
60 over 40. Okay, anyone wants to add in your answers for G and H?
I got 2 root 2 for G,
2 root 2.
and I got 3 root 15 over 20 for H.
Sorry, I forgot to simplify. I have 3 root 15 over 20 as well.
Oh, okay, okay. Yeah, okay. That's also a common thing to forget. Okay, remember on your homework, double check your final answer, right? And you check, see if any radical in the denominator, anything you can take out, right, from the square root. Okay, let's go over these steps, right? So just a few questions that has 2 answers, G and B, right? Okay, so let's start with question B. So we want to simplify right away, right, before rationalize. So for 20, I can take the pairs of 2 out, right? So that makes 6 over 2 root 5. And then we will rationalize the root 5. So that makes the denominator 10, right? 2 times 5, 6 root 5. And then outside with outside, so 6 and 10 I can reduce. So that should give you original. Oh, Brendan, right? You changed to 10.
Yeah, I did something wrong there. Just forget what I said.
No, okay. It's okay. Yeah. All right. So it should be the original answer there. Question C, right? Root 8. We'll simplify that first. Root 5 over pairs of 2 comes out. Right? So 2 root 2. And then rationalize the root 2. And that should give you the correct answer right there. Okay, very good. Same thing, we will rationalize, not rationalize yet. Okay, we'll simplify the 8. So get the pairs of 2 out. And then rationalize the root 2. And that goes straight to answer. Okay. Okay, not too hard, right? Next one gets a little bit harder because you get a bigger number there. So for 2, 4, 4, we can take a pair of 2 out as well, right? So 2 goes out, 24, and then that will give you what? 61. Okay, and then we rationalize the root 61. So you might need to do the multiplying at, on the side. So the top will be 9 root 61 over, and then 61 times 24. What would that be? 61 times 24. 1464. So I think this one can reduce into 488 then, right? Yeah, okay, so that's correct. Does anyone have questions so far? Okay, next part, okay, we can also simplify the 80. 80, I can take 4 out, right? 4 times 4 times 5. So 4 goes out, 32, and then 5 on the inside. Before we rationalize, we can see outside with outside, right? Makes the number smaller, easier to do. And then at the same time, rationalize. So you can see how I show the steps. That's what you can do on your homework. So 5 times 8 give you the 40, and then the top is root 5. Next one, okay, even though the 14 I cannot simplify, but we can do the inside, inside, outside, outside, right? So 2 and 4, I can reduce. Inside number, I can reduce each other as well, right? They are dividing, okay? So that turns out to be 2 on the top, root 2 at the bottom. So it becomes question A. Right after you divide inside, inside, outside, outside, it becomes question A. So we know the answer should be root 2 then. Okay, does anyone have questions? Of course, you can rationalize right away with the root 14, but you should still end up with the same answer, okay? Okay, last one. Last one, we can also do the inside, inside. Right, probably you guys went straight to rationalize, right? But if you look at the inside, we can reduce them, make the number smaller. And then that will give you 3 root 3 over 4 root 5. We rationalize root 5. Right, and that will give you the 20 root 15. So if you divide the inside, right, you can see that we can skip the 40, the 60, right? Skip the simplifying 60, save time. So always check if you can simplify the radical, right? Also check if you can reduce the fractions, right? Before you do rationalizing, okay? It can save you some time. Okay, I still want to cover one more, right? Because we cover the special product, okay? So we can also use a special product for two terms. The formula we are using is the third one, okay? Formula number 3, let's recap quickly, okay? Formula number 3 is difference of square. So you can look at the example 3, example C, right? Right here. When you square the first, it gets rid of square root, right? When you square the green one, it gets gets rid of the square root. So your final answer, you make the square root go away. So in other words, it rationalizes the radicals, right? Because radicals are irrational, right? So it makes the square root disappear. That's the whole point of rationalizing. So let's see what happens here. If your question has an adding, then you will multiply by the pair that has subtracting, right? Because it has to be adding and subtracting, then multiply to create the third formula, right? I'll put the formula on the top. A minus B, A plus B is A squared minus B squared. So the only difference is now we have square root in the brackets, right? So if I put square root, instead of A, I put square root A, right? Instead of B, I put square root of B. Then you can see the right side, because the square and square root, they cancel each other out. So it gives you this answer, right? So no more square root. So rationalized. So the pairs that are opposite sign, they are called a conjugate. Okay, so for example, our first one, question A, we have a square root of 6 plus 1. So the conjugate that we want to multiply with will be the one that has the minus. Okay, we multiply top and bottom by the same thing. So this is called a conjugate, meaning it's the opposite sign, okay, conjugate. So if the question has a subtract, then you will multiply with a plus, okay? So in the denominator, because of the formula, you square the first, that give you a 6. Square the second one, 1 times 1 give you 1, and then subtract. Okay? And the numerator is 2 times the square root 6 minus 1. Numerator, you still need to distribute. Okay? And then that gives you 2 root 6 minus 2 over 5. And you double check, okay? Square root 6, can we still take things out? Right, 6 is already simplified. Second thing, the denominator, does it have square root? No more, right? Used to be irrational, now it's rational, right? This is rational. We started with irrational denominator, ends up with a rational denominator. So this is our final answer. Okay, so when you finish writing the notes here, can you raise your hand? Okay, so I know everyone is up to the same page. Okay, so let's go over one more together, okay? So question B on the side, we are going to multiply with our conjugate. Okay, so what should be the conjugate here, Nathan?
Is it 3 take away 2?
Square root 3 take away square root 2.
Yeah.
Don't forget square root. Very good. Okay, so you have a plus, then you multiply with the minus. Okay, you can put a brackets around it. So now applying the formula number 3, right? The third formula, you will square the first minus square the last, right? So what would it become in the denominator column?
So it'd be 3 minus 2.
Yep, very good. Okay, so you just square the first one minus square the second one. Now for the numerator, all you need to do is just do the distribution, right? Multiplying. 3 minus 2 is a 1, right? In the denominator, so nothing to do. So you just expand the bracket on the top. Your final answer is just 3 root 3 minus 3 root 2. Nothing to simplify. Denominator is no more, right? That's it. Okay? So I would like you guys to do the last 2 questions and then we'll call it a day. Okay, we'll check answer for last 2. So question D and question F. Okay? So when you finish D and F, you can raise your hand. The lettering is weird, right? A, C, D, F. Okay, but anyways, it's the last 2. Okay, Brandon, can you tell us what's the conjugate that we multiply for D?
2 root 6 minus 1.
Yep, very good. 2 root 6 minus 1. Okay, you can put brackets if you like. And what's the conjugate for F? Eric?
Pardon?
What's the conjugate for F?
It's 2 root 3 and then plus root 2, I think.
Yep, very good. Okay, all you need to do is just change the sign, right? If it's minus, conjugate is plus. Okay, if it's plus, conjugate is minus. Okay, let's check the final answer from you guys. Okay, Nathan, what's your final answer for D?
I square root of 42 over 7.
Like that? Is that
Yes.
the answer? Yeah, okay. Any other answers? Aaron, what's yours for D? Do you have the same?
I don't have the same.
What's yours?
It's weird.
Yeah, I know. These questions are weird.
That's 24 subtract 2 root 6
2 root 6. That's all?
23. I'm pretty long.
No denominator?
It's divided by 23.
23. Okay. Colin, how about you for D?
I got the same thing.
Same thing? Okay. All right,
I
let's
have
look at,
something as well.
okay. For F, F, Eric, what's your answer for F?
I'm still finishing this one. I'm on the last part.
Yep. Colin, what's your answer for F?
3 plus 3 root 6 over 5.
Okay. And Yosher, how about you?
I have the same.
Okay. All right, so let's go over quickly, right? We'll start with the denominator. Square the first, okay, for the denominator. 2 times 2, that's 4. 4 times 6, that's what? 24, right? Okay. Minus 1 squared, so 1. The numerator, all you need to do is just expand, right? So that's 24. And then minus, and then you multiply the second one, right? Times a 1. So that's minus 2 root 6. Okay, so 24 minus 1, that's 23. And there's nothing you can add or subtract on the top. So answer is that. Okay. Nathan, do you understand?
Yes.
I have 0
Which one?
for F because the denominator is 0.
Denominator is 0. Okay.
I think I did something wrong.
Okay, we'll find out. Okay. So did you get the? Okay, yeah. So let's look at F now. Eric, can you tell me how you did the denominator?
I cancel out the 12 for. Oh wait, I should have subtracted 2. Never mind.
Right.
I have the same answer.
Okay, so you square the first. So 4 times 3, that's 12. 12 minus 2, right? And then the new.
Yeah, I accidentally simplified the 12 and the top first instead of making it 10.
Oh, okay. Yeah. So you gotta, denominator is like a bracket. You gotta figure out denominator first. And then the numerator, that will give you 6 times
It's 6 root 6 plus 6, I think.
plus 6. Yes. Okay. And then that will become, oops. That will become, we'll add in one more 9. 6 root 6 plus 6 over 10. And then we can reduce outside with outside, right? If you want to reduce, you need to make sure all the outside reduce at the same time. If one of the 6 is a 5 or 2, sorry. If the 6 is a 3, then you cannot reduce. So this one, all the outside number, they can all divide it by 2. So that makes it 3 here, 3 here, 5 here. Okay, so that ends up with this one. So make a note on the side, okay? If you get something like, let's say if the question, the answer that you do, and you get, let's say you get here, 6 root 6 plus 5 over 10. Suppose you get this, right? Then you cannot say, okay, 5 and 10, let's reduce them by 5. And then the 6 cannot divide by 10, 6 and 6 cannot divide by 5, then we just leave it. This is wrong, okay? If you want to reduce, you have to be fair. Every single one has to divide by the same number, okay? So you cannot just divide part of it. Okay, so that's all I want to cover today. So your homework will include the special product and also rationalize one term and two terms. Okay, so if you have any question, you can stay after class, and I'll see you guys next week. Okay, bye-bye.
Thank you, Jason.
You're welcome. Bye-bye.
Bye, Jason.
Bye.
Bye.